Welcome to the Same Day Podcast, where we discuss driving incremental business growth and other topics related to real estate, property management, and entrepreneurship. Now to the show at hand.
Matt Zalkum, the host of the Same Day Podcast, where I connect with top business leaders and real estate experts. A couple of past guests that I've had on recently have been Darren Huang, who does great commercial and residential real estate work. Joey Wignaraja of 19 Days is doing some awesome stuff in the studio ventures world here in Tulsa, starting companies based on identifying and then solving some critical pain points. Today's episode is brought to you by Keyrenter Property Management. At Keyrenter Property Management, we're a full-service property management company helping our clients buy, renovate, and operate real estate assets. We help our clients build wealth while taking the headache out of property management. Listen, Kevin, you know this because you've worked on a lot of these projects with us, but we've got a guy named Adam Ray. He's a great client out of Colorado. He bought a bunch of properties last year, and we immediately did 25 renovations or 24 renovations. And he's coming in this Thursday or Friday to walk, Thursday and Friday, I should say, to walk 11 or 12 or 13 more units. Because oftentimes owners don't realize when they buy underperforming portfolios, things that are specifically under market in rent, they're buying two things. They're buying an asset, but they're also buying, to some extent, a headache. We can help them manage that headache. But what they don't know often is that the properties that have been leased under market for 10 years have significant deferred maintenance, significant issues, tenant issues, and the tenants don't want to say anything because they know that they're under market, and they know that if they go and start complaining about things, the landlord or owner will have to start fixing them. And then when they start fixing them, they realize that the return is skewed, and return on investment, I should say, is skewed, and then they start raising their rents. So what you have is over time, over years, a compounding of deferred maintenance. And then because they're under market rent, somebody comes in and sees, a new owner comes in or new investor comes in and sees that they're under market, therefore they're a good buy, but they don't necessarily always calculate how much work is it's going to take to bring those properties back up to a standard where they can lease them at market rents. So Adam's coming in to walk a bunch of his properties and see the condition is not great, and we need to do a bunch of work, including adding heating and air, which is the conversation that you and I are going to have today. Let's start that in a second. But I think it's important to recognize that we can help with all of these things. We can do the entirety of the renovation. Adam will come in and walk, then he'll fund the properties. We'll do the work, we'll rent them, and then his portfolio will once again yield where he wants it to yield and where he pro-formed it when he originally bought it. That is to say, it doesn't matter what rental you have, a single-family home in any condition, a condo, townhome, apartment. We at Keyrenter have the property management solutions that you need. Go to keyrenterpmc.com or email us at info@keyrenterpmc.com. Before we get into you, Kevin, I do want to give a big shout out to Mahadev, who's a client of ours that actually introduced us to you the very first time that we worked together on a little condo at 71st and Lewis. He was looking for a solution, and we provided him with a couple of solutions for a new heating and air system. He went on Yelp or on Facebook or something, found you, was like, this guy seems great. And we were like, I agree. This guy does seem great. He does great work at an honest price, and he invoices us quickly, and we're able to pay him via ACH, drop money directly in your bank account, which is really, really critical for us so that you're not, we're not sending a check that you're then calling us 10 days later going, it got lost in the mail or anything else. I put it directly in your bank account, which is helpful for us. So often we find great vendors in our business by hook or crook. And this way, it's just like Mahadev going, hey, you got to talk to this guy, Kevin. And we went, I agree. He's the best. Let's do it. So big shout out to Mahadev, a client of ours for many, many years, for having introduced us. Kevin Evans is the owner of Liberty Air Services. He received an associate's degree in heating and air from OSU back in 2018. He's an expert on all things heating and air, having done hundreds of installs. I know because you've done a lot for us, and thousands of service calls. I know because you've done a lot for us over the past couple of years. So we're so happy that you're here, Kevin. Welcome. Thank you so much.
Oh, thank you for having me on.
I want to start just with the very, very basics for our listeners that they're not experts in heating and air. I'm not an expert in heating and air, though. I've clearly had more exposure to it than many people that would be listening to the show. Can we start with the foundational nomenclature? What are the basic components of let's start with a gas-fired heating and air system, and then we can kind of delve in once we have that foundational base.
Yeah, you've got your furnace, you'll have your evaporator coil, and then your condenser. The biggest issue that I see out here on all this stuff is, lack of maintenance. So
you have a furnace, an evaporator coil, and a condenser. The furnace generally lives inside the house.
Correct.
And the evaporator coil lives where?
It's going to be either on top of the furnace or right below the furnace. So we're either going to have an upflow or a downflow.
Okay. And then the condensing unit lives outside.
Correct.
And what is the primary function of the furnace?
So the furnace is generally where all your heat's going to come from. And it has the blower built into the furnace. So that's where you get all of your airflow. So without a furnace, it doesn't, you don't get anything. So.
Okay. So a furnace and a blower motor come together more or less. Furnace burns gas, and then the blower motor in some instances just blows hot air into the house. But other times you might have no gas running. The furnace is not producing anything, but the blower motor is actually, in this case, blowing cold air when the condensing unit's on. Right. And the evaporator coil does what?
So, your compressor is going to pump refrigerant from outside, and it's going to go into that evaporator coil. Well, it has a tiny little hole where that liquid flashes off, and that byproduct is cold air. So it's either, you have your evaporator coil on top of the furnace where your ducts are in the attic, or your evaporator coil is going to be on the ground where your ducts are, in the slab. That's generally where your cold air comes from. Okay.
So you have a furnace, blower motor, an evaporator coil, and the condenser outside is what, taking fundamentally hot air, somehow cooling it through the evaporator coil, and then the blower motor blows it into the house.
Yes, correct. So what we're doing is we're actually taking the heat from inside and rejecting it outside.
Got it. Okay. So the heat inside gets blown outside.
Correct. Thermodynamics of the refrigerant. But yeah, you're essentially taking heat from inside and rejecting it outside.
Got it. Okay. So a couple of things. There's 4 components that you really mentioned. There's a furnace, there's a blower motor, there's an evaporator coil, and there's a condenser.
Correct.
Oftentimes we get in trouble as the property management company. And I do want to get into what you said is the biggest issue that you see is maintenance of the systems. And I want to talk about how we can avoid problems that are very costly by just doing some simple maintenance. Oftentimes we get into trouble because we'll send out an HVAC technician. The HVAC technician will solve a problem. Like there's no cooling in summer. So we solve a problem. It might be a capacitor that needs to be changed. It might be low on Freon, whatever. And then 2 months later or a month later, we have another issue. And the owner says to us, we just had a maintenance technician out there. We just had an HVAC tech out. Why am I getting 2 bills within 2 months? And my point to them is the system is complex. Mm-hmm. It's like the human body. If you break your left arm and now you have no use of that arm, you're going to be doing a lot more work with your right arm, and your right arm is very likely to start hurting. That's not because the doctor didn't set your left arm properly and fix that broken bone, but it's because now it's carrying more weight with your right. Now you're doing more stuff that you wouldn't normally do, and that puts additional strain on your right arm. What are some things that you see in terms of the overall system being hurt on the left arm and then needing to carry weight on the right arm that causes it to the right arm potentially to break, so to speak?
So I would say the biggest thing is tenants putting in air filters. If a tenant has an air filter in and they don't change it for an entire year, we're going to hit some major issues somewhere.
And what happens?
So your evaporator coil is either going to start freezing up and sending liquid back to the compressor. You don't ever want to send liquid to any compressor. These newer compressors, they can handle it for a while. Eventually they're going to say, I can't handle it anymore, and either blow up or pop fuses, throw safeties, stuff like that. Cleaning the condenser. You could come out there and clean it. And, they could come out there. So, the tenant could mow 2 or 3 times, blow all that stuff onto the condenser. And now it's going off on a high head pressure. There's stuff like that is really not much of in our control that tenants can really mess these units up.
So what happens if you don't change the air filter? What happens? Is it that it's not getting enough airflow because there's blockage in the actual filter and there's dust? Or is it that dust starts working its way into the evaporator coil and does something to the evaporator coil?
So if you leave an air filter in and it gets clogged just for a few months, most likely you're just going to be sending liquid back to the compressor. But if a tenant has an air filter in there and it's been in there for years, that dust and dirt's definitely going to bypass that filter and just go right into that evaporator coil. So once that evaporator coil starts getting plugged up, just like the filter, it's definitely going to cost way more to take that evaporator coil out to clean it than it would have been just to replace the filter.
And what does it mean to send liquid back to the compressor? You say it's not good to send liquid back to the compressor, but what is that? What liquid is that? Is that gas? I mean, you're talking about Freon,
yes, refrigerant.
Refrigerant.
So as soon as it hits the evaporator coil, there's a tiny little hole, and it flashes off into a mixture of liquid and vapor. Before it gets back to that compressor, it has to be a total vapor. It has to have that heat rejection. So if we're not getting enough airflow across that evaporator coil, eventually you'll start sending liquid back to the compressor because it didn't have enough time in that evaporator coil to sit there and go to a vapor. So we definitely don't want to be sending any liquid to the compressor.
And so liquid to the compressor is just over time will damage and destroy that compressor?
Correct.
And the compressor is part of the condensing unit that's outside. That forms one part. The condensing unit outside has the fan and the fins and has a compressor that's doing what fundamentally?
So we're taking the temperature inside. We boil off that refrigerant. It comes back out to the compressor, gets pumped into a high pressure gas. The condenser rejects that heat, bringing it back down into a liquid and sends it right back to the evaporator coil. So it's just a big cycle.
Got it. So it goes back and forth. So one thing that can destroy a condensing unit, the compressor inside specifically, is not having a clean airflow that's going through a filter and then into the evaporator coil. Right. Another is having the fins, having the external unit clogged. And what is that? If somebody mows their yard a couple of times and it gets onto the outside condensing unit, what happens? It clogs the fins, and those fins are actually used to reject heat. Is that right?
Correct. Yeah. So I mean, that coil out there, it's supposed to be rejecting heat. Well, if it can't reject heat, then we're sending hotter liquid inside. In turn, once it gets there, you're going to have a higher evaporator temperature. So on a clean condenser, you should have somewhere around a 40-degree evaporator temperature. If we get really high head pressure from that being really dirty, the lowest that evaporator temperature might get is 55 degrees. So that's a big difference in 40 and 55 for, how long that system has to run, and actually bringing that temperature down. So, yeah,
interesting. One thing that a lot of our clients ask us about, especially on remodels, is is it cheaper to do mini splits with multiple heads, maybe one condenser, two condensers, many heads, as opposed to a full split system, right? A full furnace, evaporator coil, blower motor, and outside condensing unit with ductwork. And obviously the ductwork costs money to run if it's not there already. If it's already there, then it's great. You just hook up to it. But I've always found in running the numbers that if you have a house, forget a studio, for example, where a mini split actually might make sense because it's just one fundamental space. But if you have multiple rooms and you can't get the airflow from one mini split head into a bunch of different rooms, and it's not more cost effective to do, either one mini split with multiple heads, one condensing unit with multiple heads, or two condensing units with and then multiple heads. So 4 heads, for example. What are the benefits of mini splits for our owners that are looking to do remodels? What are when is it appropriate to put them in? When is it really better and cheaper, more cost effective just to run a full split system?
So for like you said, a studio apartment, perfect. Mini splits are absolutely perfect. But once you have a house, let's say it's a 2-bedroom, 1-bath home, and you decide to do 3 heads, maybe 2 condensers, you're going to be up there in the price of, $8,000-9,000 for all of that. Whenever a full system with ductwork might have cost you 12 or 13. But the downside to mini splits is they don't last as long as a split system does. If you're doing just a 1-head mini split, the cost is quite low. As soon as you go to a 2-head mini split, that price almost doubles.
And why is that? Because there's significant componentry in the actual head as opposed to the condensing unit?
It's actually the condensing unit that costs way, way more. So instead of just having one port come out of that condensing unit, now we've got multiple ports. So it's going to have to do some, pretty fancy stuff inside that condenser to determine which head actually needs the cooling. So there's way more that goes into that condenser than just a single head unit.
And so once you have a mini split system, how are they heated? I mean, we know about the cooling side. I mean, that's the same refrigerant explanation, evaporation that you just discussed. But how are they heating? Because you don't have a furnace and a blower motor in that scenario.
Yeah. So what those are heat pumps. So in the wintertime, it reverses, instead of putting your heat outside and cold air inside, it reverses. It puts the heat inside, cold outside. When we're talking heat rejection, that temperature outside the condenser can always get colder than the outside air. So if it's colder than the outside air, it is rejecting heat. even though it may be 20 degrees outside. And mini splits are good about, it could be -5 in most cases, and your mini split will still work. Once you get down to -10, -15, that's where we really start to see decreased performance. And then the tenant may have to use a space heater or something.
Right. Which draws tremendous amount of electricity. And we see breakers flipping and all sorts of issues. We have in Colorado, I just got back from Colorado. I was on vacation with my family. We've got in our house there, we've got 2 outside condensing units, and yet every room has the ability to change the temperature in that specific room. How does that work? I mean, I know at my house here, I've got two condensing units outside, and I've got 2 thermostats, and I can only change it. I can make sections of the house cooler or warmer. But in Colorado, we have the ability to do it in each individual room. How in the heck does that work? Okay,
so that would be a zoning system. So on each room tied into your ducts is going to be a flapper type thing, and it's motorized. So if you want colder air in your room, that duct is going to open more, giving you colder air. If it satisfies, that duct's going to close, pushing more of that air to the other rooms that are calling for cooling.
Beautiful.
So zoning systems are expensive to put in, but they are phenomenal for comfort.
But so basically, just take, for example, one condensing unit outside. If room A says I want air, room B says no, then your system is running outside. The condensing unit outside is running, and then A says no and B says yes. The system's still running. So the system's going to be running until such point that no room is calling for cool air. Is that right?
Well, so most of the time it would have to be to where 2 or 3 rooms are calling for AC before it will come on. Because you don't want to be sending, let's say, 5 tons of air down into one room.
Right.
So generally, 2 or 3 will have to call for AC, then it'll come on. And then once those rooms all come back down, then it shuts off and starts that process over again.
Got it. So we just don't see in Tulsa. I don't see a ton of those. You and I don't install a bunch of those in our houses. Renovation. It's just because it's so expensive. Correct.
Bigger, higher end houses have zoning systems, but most of rental properties are not going to have that.
And what's the expense? The actual it's some technology, and then there's mechanization associated with the duct opening and closing. Is that right?
Correct.
But is a condensing unit more expensive, or is that the same?
No. Yeah, the whole AC part of it is going to be the exact same. So the zoning system, you're just adding into the ductwork. Just on parts, you may be $1,500 to $2,000 plus the labor to stick all this stuff in, make sure it runs right. So it is a pretty big cost to add it. So,
got it. So let's switch for a second. We might get 2 or 3 bids from different contractors, different HVAC contractors to do a new system install. What are the components of the cost? Sometimes we see like $1,000 of cost difference. I would think that there's materials, and that includes a markup for the contractor that's doing the work. There's labor. I guess that's it. There's really material and labor, but there are various components to the materials that I want to get into. But generally speaking, how do HVAC contractors price a system, and why would there be difference in me bidding a 2.5 or 3.5 ton system at a house?
Yeah. So, if we have let's just say a 3-ton system, what we do is we come look at the home. We would take the cost of the equipment, add our labor in on top of it, and then we have a profit margin that the company has to stay within. And generally, we base all that off of how hard the job's going to be. If we think that there may be some warranty issues with maybe the location of the furnace, you may have more issues by sticking a system in an attic versus putting it in a closet. So, that's generally where the cost of everything comes from. And your manufacturers, there's going to be a pretty substantial difference between prices of manufacturers. A Goodman's going to be one of your cheapest. Train or Lennox are definitely going to be quite a bit higher than a Goodman. So, and
is that just like buying a Ferrari versus a Toyota? I mean, in I guess in that analogy, a Toyota can run for 300,000 miles. A Ferrari probably can't. There's more maintenance required, even though it's a much more expensive system. So maybe that's a bad analogy. But are you getting for what you pay for, or are you just paying for the name brand, shiny paint on a Ferrari, as opposed
most
to
of the time you're paying for a shiny paint on a Ferrari? Yeah, most of the time you're paying for the name. Especially whenever you go Lennox or Train, most of their builder grade stuff, which is going to be the lower tier, they're generally all going to be the same. The only one that really does things different is Amana. They put Copeland compressors in, high pressure, low pressure safety switches. They do a lot of things on even their basic builder grade model that a lot of other manufacturers don't do. And it may only be, an extra $200 or $300 to get that system compared to a Goodman.
Okay. So instead of putting in a Goodman, which is a base model, maybe a Hyundai or something, maybe some manufacturers going to come back to me, some manufacturers going to come back to me and sue me. But basically, instead of going for the lowest brand, you can go a little bit higher and have, in essence, better componentry, better system. So it's better value for the money that you're paying, even though it's a little bit more expensive. Yeah,
that's correct. So Goodman on their compressors, the compressor is the heart of the system, especially for cooling. If that goes out, there's no cooling. Goodman you never know what kind of compressor you're going to get with a Goodman. Could be an LG, that could be really Samsung. It could be any kind of compressor in there. And those cheap compressors don't last near as long, especially if they get abused. Amana, they only put in Copeland's, which has been around, one of the longest compressors around. Copeland's are phenomenal. Those Amanas, high pressure switch, low pressure switch. It's got an intelligent monitoring system inside the condenser. So if it senses, hey, the capacitor just went bad and I can't start, instead of that system sitting there trying to start for days and days and days, it'll completely lock it out until somebody can get there, fix it so it doesn't harm the system.
Got it. So in essence, you pay a little bit more for the compressor itself, higher quality compressor, and the safety system, such that if the thing fails, it fails smart. It doesn't just fail and break.
Correct.
And so instead of replacing a compressor, which might be $1,000, you're now just paying for a tech to come out and solve the underlying issue, which is low on refrigerant or air filter that's caused some sort of other issue.
Yeah. So especially with compressors too. Ever since the pandemic hit, compressor prices have just been skyrocketing. If you can't get one under warranty, you're right around $1,000 just for the price of one of these small compressors. So, the price just keeps going up higher and higher and higher. So, it's really best to try to really protect that compressor. And that's what Amana does.
We often have owners that say, I should have 2 years ago, a full system was $4,500. Now it's $7,000. I should have just replaced the compressor 2 years ago when I got that bid from so-and-so. Now we're dealing with a bad system. I try to limp it along. So that's always the challenge. Do we try to get an old system to limp along? Forget for a second the difference in cost between R22 refrigerant, which is now the EPA said we can't sell it anymore. So it's a scarce commodity and it's getting higher and higher and higher. And 410, which is an abundant resource that we can always put in. But the tendency to limp a system along as opposed to fixing it new. Tell us about some of the pros and cons in terms of an investor's mentality of trying to spend as little as possible so they can maximize their ROI.
Yeah. So especially with 410A, that's what we're using right now. Just 2 years ago, I could pick up a jug of 410A for right around $97, an entire drum of it. Now the price is close to $600.
Wow.
And it's been that way for about the past year.
Do you think it'll come down when supply chain constraints?
No, because next year, the EPA has mandated that we go to SEER 2 and we change our refrigerant again. So 410 is getting ready to be just like R22, where it starts to get scarce and the price is going to go skyrocketing even higher.
So manufacturers can no longer manufacture 410A as of next year or whenever.
That's correct. So once we go to the SEER 2 rating, which is January 1st, the manufacturers are going to have a different kind of refrigerant.
So is there any purpose? Should we start stocking up on 410A while we have it, while we have the ability to buy it?
I don't know. Refrigerants like the stock market. One week it'd be down to $300 a jug. The next week it could be up to $800. In my opinion, $600 is still high. If it comes back down, I may buy a tremendous amount of it, but I think buying it right now is I probably wouldn't buy a tremendous amount of it.
And so starting January 1st, we're going to have the same conversation about a 410A system that we had with an R22 system, which is you can continue to plug this leak or try, but every summer when we're leaking refrigerant, we're going to have to replace it with an ever increasing cost of refrigerant. You might as well, there's an inflection point where it just says, look, I know the system's only 8 or 10 years old, but we should just replace it because you're going to keep putting in really expensive refrigerant, and you might as well, the cost long-term of operations is going to be greater than just replacing it with a new SEER 2 system. What is SEER 2, for example?
So SEER 2, right now, our normal SEER rating, 14, 16, 17, 18. how manufacturers get that SEER rating in the lab is they pretty much just set it on the bench, turn it on, and they get their efficiency rating. Now the government has mandated, telling the manufacturers that they have to have a certain amount of external static pressure before they can get their SEER rating. So they're mimicking actually having a system in a home hooked up to ductwork now.
Got it.
The downside to that is the new SEER 2 equipment for a full system is about another $1,000 extra versus regular, the SEER rating we have now. We've been having issues getting units for about the past month or so because January 1st, the government's told manufacturers that if you still have equipment left over January 1st from the old SEER rating, you can't even sell it.
Wow.
So right now they've completely pretty much stopped. Well, they haven't stopped manufacturing, but they're not giving suppliers new equipment until they sell out of the old stuff. And then the SEER 2 will start trickling in. So right now we're at a point where it's getting hard to find equipment.
Wow.
I just bought my first SEER 2 complete system last week, and it was an extra $800. So
wow. So now as we start installing new systems, we're going to just be putting in SEER 2 systems. It's just correct. It is what it is. We had a client recently say, we had you out to install a new system. We had, I guess, 2 issues within a month, and you said, look, we got to replace the system. And I should take one step back here and say, over in Arkansas, we were working with a vendor recently who said, like, look, the truth is the furnace is not bad, but I would just install a whole new system. Of course, the client thinks that the vendors are trying to upsell. The client says, well, what's wrong with the furnace? Well, nothing really, but as soon as you start changing out the compressor, you've got a mixed system now. I've got a Goodman furnace with an Amana, compressor outside, a condensing unit. That causes problems in terms of it speaking together. I can't tell you whether it's going to be a problem. It could work for 10 years with no problem, and it could cause a problem immediately. So we end up replacing just the half system, the cooling system, and not the furnace. They install the system, and then the contractor comes back to me and goes, the blower motor just is not working. And I can't tell you why. It's just, again, it's a complex system, but we really have to replace a blower motor in the furnace. And now all of a sudden, a $3,000 job becomes a $5,500 job or whatever it was. And the owner's like, what's the deal? And is somebody trying to screw me here? And the answer is, I think the contractor's honest. I think it wasn't a bad install job. It was just that sometimes you mix components, and if you don't replace the whole thing, it doesn't work. Why does a system just not work when that happens in that scenario?
If you have, let's say a 10-year-old furnace, and it's an upflow, and you need to replace the evaporator coil and the condenser, you can generally keep that furnace. If we're talking a 40-year-old furnace, especially a downflow, I always recommend, if we're going to replace the evaporator coil and condenser, to change that furnace too. The reason being is the new evaporator coils are almost twice the size of ones 20 years ago. And if the furnace is sitting on top of that old one, that furnace either way has to come out of the closet or come out, the attic spot that it's in. Then we've got to put our new evaporator coil in, tie in the ductwork, put the furnace back, make sure we didn't mess any of the old components up on the furnace before we set it back over there. We're already doing the labor of even, adding a new furnace, or, even if we have to remove an old one. So might as well just go ahead and get all 3 pieces swapped out. Then you don't have to worry about it. It's under, the warranty. It just saves a lot of headache down the road. Yeah.
Yeah. We had another situation recently where you went out to bid a system, I don't know, $7,500 full system. The client said, let me call somebody else, called, their friend who is a licensed HVAC contractor. And that contractor went out and did it for like $2,500. What happened was the other contractor went out, he went on Facebook, he found a used system. He, drove out, and you and I spoke about this. He drove out to God knows where in Coweta or something to pick up the system, and he went and installed the used system. From my perspective, I say to the client, like, our vendors are not going to, first of all, it's an incredible amount of labor to source it on Facebook. So if you're billing $100 an hour for labor, you're going to Facebook, you're spending an hour or two to find it. You're driving out, there's fuel, there's wear and tear on your vehicle. You're going to pick up a system, you put it in, you start it up. You have it's sitting in somebody's lot. You have no idea whether that system's going to even kick on when you did it. Now you've spent $2,500 to buy an old system. And I tell them, look, Kevin Evans he's a real businessman. He's got people on his team. He's got an admin staff. He's got time. His time is not free. Like, doing all this, it's just not an offering that any of our vendors that we use on the HVAC side are willing to suggest, because you just don't know. I mean, what if you go out and you buy $2,500 worth of system, used and you have $1,000 worth of labor in it and you install it and it doesn't work. And then you're like, well, that's $3,500 that I got to bill you for. And by the way, a new system is $7,500 and it's out of stock because I didn't put it on hold when I had the opportunity to. Now it's harder to get the part and you're going to pay $7,500 and the price just went up. It's like now you're in $10,500 or $12,000 for a system when you should have just done it right the first time. It's a hard spot to be in. And I talk a lot about on the show about appliances being the bane of our existence because a $500 install of a new dishwasher is one thing, but a $250 fix or a $300 fix for a 10-year-old dishwasher is another thing. And owners hate us either way. I always say put in a new dishwasher if it's older than 2.5, 3 years, because you could end up with a scenario where you spend $250 or $300 to fix it. It doesn't work. And then you're buying the $500 dishwasher anyways. Then you're in for $850 or $900. Like it's just terrible. What's your experience with that? I mean, you probably have people tell you that all the time. Can you just get something cheaper? I mean, what's your experience?
Yeah. I mean, back when I first started, every now and then I would put in a used condenser, or something like that. And then, the system would only last a year. And I would tell whoever I was doing the job for, like, listen, this thing may run for a day. It may run for 3 years. If it goes out tomorrow, I can't do anything about it. So that's why we always suggest put in, just swap all 3 pieces out, get it over with. And then you're good with either the 10-year warranty or the Amana lifetime warranty. Right. So, I mean, it's definitely more of an upfront cost to replace everything all at once, of course. But it definitely is going to save you money down the road.
It's stepping over pennies to pick up dollars. No, stepping over dollars to pick up pennies. I guess is the expression. So the other scenario that we have often is no cooling. You get a call for no cooling. We send you out. And the system is showing low on refrigerant. Why does it have? Why do systems get low on refrigerant?
So most of the times it's going to be a leak in the evaporator coil. And the way that we tell that is we turn the system off, take the panel off the evaporator coil. We have what we call a sniffer, and it tests for refrigerant leaks, and we can go through there and determine where the leak is at. On older systems, we could do a complete leak search and sometimes not find the leak. If it's just a little bit low on refrigerant, then that leak may be so small that our sniffer can't pick it up. So adding a pound or two, is fine. But if we go up on a system and it's completely out of refrigerant, we generally throw nitrogen at it, get it up to 300-400 psi, and we can definitely tell where that leak is coming from and resolve that issue.
And like, why does there become a situation where there's a leak in the evaporator coil? I mean, it's just metal rusting, it's corrosion. Like what's happening?
You got corrosion, metal rusting. You've got cycles, every year where we put that evaporator is cold, the winter it's hot, cold, hot, cold, hot. You do that for years and years and years and years. You're eventually going to get a leak somewhere.
And it's literally, you got a metal tube, and then the tube gets thinner and thinner and thinner. And then eventually, like a pickup truck that you see on the side of the road from 40 years ago, it just, the metal just starts corroding and rusting or whatever.
Yeah. Yeah. And most of the times on these evaporator coils, especially when they're, 20 or 30 years old, you can attempt to fix them. But more likely you're just going to blow more holes in it. And especially on the 410A systems, they're double the pressures of R22. We're seeing way, way, way more evaporator leaks on these 410 systems.
And so when you say fix them, you mean like weld, you basically put a metal weld over a hole.
Correct.
And that will hold. I mean, does that generally hold for the long term, or is it kind of like pop a mole? It holds, but then it creates there's more pressure somewhere else. So it goes to the next weakest spot in the system.
Exactly. So we could fix it. And that may last for a few months, or the next week we may have a completely separate hole somewhere else. Whenever evaporator coils start blowing holes in them, it's always best to just go ahead and change it out, or you're just going to waste, really waste money.
What does an evaporator coil cost in August 31st, 2022?
If you're going to buy just an evaporator coil, you're somewhere around $600 just cost of an evaporator coil.
And then the labor to install it.
And then with the new SEER 2 rating, all evaporator coils have to have TXVs, which is a thermal expansion device installed on them. So they're going to be about an extra $200 just for that evaporator coil.
And what is a thermal expansion valve? I think TXV stands for thermal expansion valve, right? What does that do?
Correct. Okay. So, 14 SEER systems, most of the times people just add what we call a piston into that evaporator coil. And what that is just a tiny little hole. So we can raise lower head pressure outside of the condenser to determine how much refrigerant passes through that evaporator coil. On a TXV, it senses your suction temperature, it senses your suction pressure. So say a tenant leaves an air filter in and it starts getting clogged. That TXV will start slowly closing down, letting less and less refrigerant in to make sure that no liquid goes back to that compressor. So a TXV definitely helps save the compressor, gives you better cooling versus just a piston, which we call it, a dumb old hole. That's all it is.
Yeah. Got it. Interesting. When oftentimes we find systems will stop cooling or will cool less effectively, and residents that have the temperatures internally set inside their house set at 72 will go down to 62, thinking that it's going to cool better, and then the whole system freezes up. Like, what is that? What is happening when a resident does that?
Okay, so most of the times, if they're turning it down to 60 degrees, most likely there's already an issue somewhere. We've got a dirty blower wheel, a clogged up evaporator coil, stuff like that. So whenever they turn it down to 60, at nighttime, it's going to try to get down to 60. And especially if you're already plugged up on your evaporator coil, blowers dirty, stuff like that, then you're most likely going to freeze up, and that evaporator coil is going to become a big block of ice.
So what does freeze up actually mean? The evaporator coil becomes a big block of ice. Like, what does all that actually mean?
So on your evaporator coil, you don't want it to get below 32 degrees. So if we have low airflow, or another symptom is low on refrigerant, what it'll do is right at that piston or TXV, it will start freezing right there at the actual device. And once it starts freezing, it just starts getting bigger and bigger and bigger. And that ice will come all the way around. And sometimes it'll go all the way even out to the compressor. I'll see some compressors with 3 inches of ice all the way around them. So definitely low on refrigerant, low airflow.
And that's because the blower motor is not effectively pushing enough air over that thing to take the cold air out of the system and into your house. And it just gets too cold right there and freezes up.
Correct. Especially if you have a dirty blower. It can't push enough of, let's say the room is 75 degrees, the house, and that evaporator coil is 30. Well, it needs to push a certain amount of air through that evaporator coil so that evaporator coil can pick up heat. If everything's clogged up, that evaporator coil can't pick up heat. And then all of a sudden your evaporator temp keeps getting lower, lower, lower. As soon as it hits 32 or below, it starts freezing up.
Got it. Okay. So, and we suggest then residents shut off the system in its entirety, let everything unfreeze, and then that thing thaws out. Then when they turn the system back on, even though the fundamental problem is not solved, which is a dirty blower wheel or whatever, it can now start cooling again because it's thawed out. And now whatever air is passing over that little spot where it's pushing cold air into the house, that's happening again, in essence.
Yeah. They can definitely do that. So if they ever notice that it does freeze up, completely shut off until everything thaws out, of course, they need to make sure that we are on our way out there, that we know of the issues so we can come out and figure out what exactly is wrong with it. But to get them by, they could run it. If it freezes up, thaw it out, and then let it sit for a little bit, and then they can turn it back on and get some more cool air.
So one thing we had that happened 3 winters ago, we had incredibly cold temperatures, and there were some very high efficiency heaters that extract humidity from the air, and they blow that humidity drips out through some sort of drain line and goes external. And the liquid that was coming off the system froze up through the whole PVC pipe that's going out of the house, froze up and came back into the system. And then because water wasn't able to get out of the system because it was frozen in the line that was taking it out, the whole system shut down. These are high efficiency heaters. And so the entire system shut down in the coldest part of the year. And the only thing that you can do is because the air outside is cold, it's not going to thaw out, is either thaw out that line. So figure out and you see in Colorado, frankly, you see a lot of low voltage heaters that are coming out of everything from guttering and drain lines that you never actually lose the ability to drain water. You might see it in one of those lines also. So it never freezes up. But the only thing we could really do was create a scenario. We would have to tent a heater with plastic, heat the heater with electricity, like a space heater, so that it would get to a certain temperature so that it would start heating again the whole house, which is crazy. I mean, how do you avoid that scenario, and what can you do, just generally speaking, other than what I suggested if that happens?
Yeah. So really a 96% furnace really needs to be inside, like in a closet. But
and 96 is a high efficiency.
Correct. Yep. So the byproduct of them, whenever they run heat, is going to be water. What it is condensation, because it's actually getting all of the heat out instead of, letting, 20% of the heat go out the flue pipe. We're only letting 4% come out of the flue pipe. So you get some condensation inside.
Got it.
All of your drain lines, especially if they're in an attic, really need to be insulated. And even then, whenever it got to, -10, -15 here,
yeah,
even the ones with insulation on it were cracking, freezing up. Around here, that was just definitely one of those one-off things that hopefully doesn't happen for a long time, because I can't tell you how much PVC I had to replace. There was a lot of it, and a lot of, especially in houses that are 2-story, there was a lot of homes that had to do insurance claims because water coming through the ceiling, making it down to the first floor. I saw one house that had a tankless in the attic, and it froze. Wow. So that destroyed a lot of the house.
I mean, just crazy to think that you have to take the space heater that you're using. And once your heater shuts down, you've got to use a space heater that you're using to heat your home and keep you warm in -10 degrees outside or 15 outside, and use it to heat your heater so that you can overall heat your house again. Crazy.
Oh yeah.
Tell us a little bit, in your experience, what do you suggest on just preventative maintenance, semi-annual, annual, quarterly? I mean, what do you think is the right way to do maintenance, and what do you do when you go and do preventative maintenance at any period of time to a unit?
Yeah, so I think you should have it done twice a year. One in the springtime, one in the fall. The one in the springtime, we're gonna clean your condenser, check capacitors, contactors, check refrigerant level, make sure our temperature split inside is good. And what that is we take our return temperature and our supply temperature, and we take that difference, and that's our split.
What should a normal temperature split be?
Around 15 to 20. Now, if you're getting in the 8, to 10 range, then we may need to slow the blower wheel down, or do some other things to get that temperature split. But that would be for the summer months. As soon as we hit winter, we come in. That's whenever we really take a temperature rise, because your furnace is definitely going to heat up way hotter than the air that it's bringing in. So if you have a slightly dirty blower wheel or a clogged air filter, it's going to start hitting high limit safeties and completely shut the system down. And especially on the older systems, instead of it just locking out, it'll run, shut off until that high limit resets, and then run again. So you'll go into some of these houses, the furnace may only run for 30 seconds before it completely shuts off. Then it's got to sit for a few minutes, and then it'll run for 30 seconds, shut off. So that's the type of stuff that we're trying to get to and find and fix it. If a furnace does that for too long, it could put holes in the heat exchanger from that huge temperature difference. But that's what we're trying to prevent whenever we go twice a year.
Got it. I love it. Kevin, thank you for being on. This is super, super helpful.
Yeah.
Kevin Evans is the owner of Liberty Air Services. Kevin does a ton of work with Keyrenter. We really appreciate you being on the show. We also, much more so, appreciate you being a great vendor, a quality HVAC technician. Appreciate everything that you do with your team.
Yeah, thank you, Matt. Thanks for having me on.
Thank you for being on.
All right. Thanks, sir.
Thanks for listening to the Same Day Podcast. Tune in to a new show each week and be sure to subscribe to get future episodes.